I want to introduce a little bit of notation related to finding the area under a curve. So if we have a bunch of rectangles and we're going to use those rectangles to approximate an area under a curve, we're going to let n equal the number of rectangles. L sub n would be the estimate of the area using left endpoints, and R sub n would be the estimate of the area using right endpoints. And delta x will be the width of each rectangle. And we're going to assume that all of the rectangles have the same width. So let's look at an example. Consider the following function. F of x equals 1/2 x squared minus 4x plus 10. So the first thing we should do is try and graph this. So we're looking for the area under the graph on the interval 1 to 4, and we're going to use 6 rectangles. So let's graph this function. What do we know about it? Well, we know that f of x is a parabola that opens upward. We know it's a parabola because we have an x squared term here. Looks like something that would be making a parabola, and it's opening upward because the coefficient of the x squared term is positive. We have a positive 1/2 here. And the derivative of this is x minus 4, and if we set that equal to 0, that tells us that we have a minimum at x equals 4. We know it's a minimum because the parabola is opening upward. And if we plug 4 into the original function, we get 2, so that tells us that the minimum is at 4, 2. So that gives us some information about this parabola. We could also plot a few more points to get the general curve. This is what it would look like, and we're interested in the area under the curve of this parabola from 1, so here's 1 right here, all the way to 4 right here. So we're looking at trying to find this area right here. Okay, so let's actually try and compute the area. And remember, we're trying to find the area from 1 to 4, and we're going to use 6 rectangles. So n equals 6, and delta x, which if you remember was the width of each rectangle, is going to be 1/2. And how do I know that? Well, imagine here we're looking at from 1 to 4. So the length of this interval would be 4 minus 1. That would be from 1 all the way up to 4. 4 minus 1, that's 3. And then we want 6 rectangles, so we're dividing that into 6. And that gives us 1/2. So with 6 rectangles, each one's going to have a width of 1/2. And if you look, that does make sense. Okay, so the first thing that we're going to do is we're going to look at left endpoints. And it would probably help if we had the values of our function that we could plug in to get the height of the rectangles. So here's a table of values for x and then f of x from 1 up to 4 in half-step increments. And now let's look at left endpoints. So for left endpoints, we're going to call that L sub 6. And L sub 6 will be the area of the 6 rectangles using left endpoints. So the first rectangle is going to start at 1, and it's going to go all the way up to here. And since the left end of the rectangle determines the height of the rectangle, that's what it means to use left endpoints. This is going to be our first rectangle. Remember, it has a width of 1/2. Okay, so this one has a width of 1/2, so I can put the 1/2 here. And a height of, well, f of 1. F of 1 is 6.5. So this is 6.5. And that right there is the area of my first rectangle. And I'm going to have 5 more of these. Okay, so the next one then is going to be right here. Remember, the left end of the rectangle is determined by where it hits the function. And so that is my next rectangle. Again, it's going to have a width of 1/2. And the height is 5.1. That's where it goes up and hits the function at 1.5. So that's 5.1, according to the chart there. 5.1, and then I have my third rectangle, so that's going to look like this. So that also, they're all going to have a width of 1/2 here, the width of 1/2. And then a height at 2, it's 4, so this is 4. And then the next one we have also is going to have a width of 1/2. Let's take a look at the height. So here is the height right here, right there, and then come down to 3. And so that would be at 2.5, so that's 3.1. All right, we're almost done here. We have 2 more. So now I have one that starts here and goes over here. So that is going to be now a height at 3. And at 3 we have 2.5. So that's 2.5. And then the last one we have, again, a width of a half. And it's going to look like this. And that's going to have a height of 2.1. And so if we add up all of these 6 rectangles, we end up getting 11.65. And that's going to be my L6 value. That would be the area approximation using 6 rectangles and left endpoints. Okay. So now I want to do the same thing, but I want to calculate R6. So that's going to be using right endpoints. And to use right endpoints, the first rectangle now would go up to here and go over here like this. So it's going to be this rectangle right here. And so again, it's going to have a width of a half, and a height this time is determined by the value of the function at 1.5. So that's 5.1. And then these are all going to have widths of a half. The next one then is going to be this rectangle right here. And that's going to be 4.0. And if you notice, this kind of looks like using left endpoints, we're just kind of off by 1 in a sense here. So this next one, instead of 4.0 here, now we're at 3.1. And let's check that. So that would be this right here. That'd be the height at 2.5. 2.5 is 3.1. Yeah, so this works. And then the next one we have should be 2.5. And then let's check that. So that would be this one right here. And the height is determined by 3, and the value of 3, yep, that's 2.5. And we have 2 more here. The next one is 2.1. And that would be this rectangle right here. And that's 2.1. And then the last one is one that we didn't have with L6, and that's going to be at 2.0. That's the last rectangle here, and that's this one right here. And so now if we add these up, we end up getting 9.40. And that's my value for R6. That would be the area using 6 rectangles and right endpoints. Okay, so to summarize, using left endpoints, we had an L6 value of 11.65, and if we looked at the graph there, that was an overestimate. It was over the graph. And R6, which was 9.40, was an underestimate. And so the actual area is 10.5, and that does fall within the range of 9.4 to 11.65. Now, if you wanted to get a better estimate, you could use more rectangles. The more rectangles you use, the narrower that range is going to get for the estimates.